All right, welcome to another coding session. Continuing with Bangalang, our, what do I usually say? It's our low-level explicit procedural compiled language that runs on the CPU and the GPU. We have our little playground here, which is where I've been trying some new features. You know, we have these range for loops, which are nice. Quite happy with that. We have do here, which is like a single line scope, which I think is quite nice. You know, we could put it in curly braces, but we can just use a do if it's just one line. Well, one statement can fit in a do scope. What else? We got our allocators working nicely. We've got enums, and we started on generics. And when I sort of reverted this to what it should be, not yesterday, when I last did this, I forgot to put the equals there, which is interesting. This is because I think I did this also during the last session, and I ran it. Oh, we're running OpenGL. Let's run the playground, and we get this error, right? So the thing is that, so with the syntax of my language, it should be equals. You need to say, you know, this is the name of a variable, this is the type, so it's a procedure. Then you have to do equals and then the value. And the value of a procedure is a procedure body. In this case, we're using, like I said before, the do scopes, because it's just one statement, so I say do the statement. And when we emit that equals, effectively it's like this. You know, effectively it's like two lines, two different statements. This is a procedure that has no body, which should not be allowed. And the reason I don't allow it is because like this equals is kind of weird. Like a lot of people, like in a lot of languages, you would expect it to be something like this, right? And then I do my stuff. That would be like a normal procedure definition, right? You put a name and a type, and then you put your body here. This equals is a little bit weird. So what I do is, if I see something like this, I say, no, that's not allowed. You need a procedure body to prevent accidentally doing this, which you might do. In our case, we've got an error. The compiler's throwing an error. And I think it's to do with the return, yes. And I've actually, if we go to our list, I've actually had, this is right at the top of my bugs, fixed return for main procedure, because it's broken. We've got a note about it here. And that's because this code here is trying to get the return type of a procedure, but when we're in the main body of a module, this doesn't work. And it's actually not that hard to fix. So this here is saying, you know, do we have a value to return? Okay, and now I think we want to say if length of context.path is greater than 2, then we do this stuff. We don't need this to do, because we're doing it. We want to get the return data type. And because if the path is less than or equal to 2, that means we're looking at the main body of a module, like this. And in that case, our return, what it does, if we go to generation, we can see what it does. Not call, return. You can see, so here it's, we should have the same condition here. So if the length is greater than 2, then it does a regular return, right? See, it prints out the return instruction to the assembly. It copies the return value if there is one, and takes care of all that stuff. Otherwise, if we're in the main body of the module, it does a syscall, which is the exit syscall. So it'll just exit the program with whatever you return with. And what we return with, that type, I'm calling that a U8 at the moment. So we can just say return data type equals context dot program dot identifiers U8. That's the default. If we're not inside a procedure, this is our data type. Otherwise, I'm going to say return data type is this dot this, because the data type of a procedure has 1 or 2 children. The first child would be the parameters, the types of the parameters, and the second child, this guy here, is the type of the return type, the type of the return value. And because we've established here that this return does have a return value, that means that this will exist. So now we can put this here, and we should have the right return type for if we're in a procedure, or if we're not, we should have the right return type. If we go back to, I don't think we need to change anything here. We fixed up this. So now if we run it, me has not been declared. See, this is a more rational error, because if you think of these as 2 separate statements, me was declared as part of this type, so it only exists within this procedure. This is totally separate, so it doesn't know anything about me. So if I do return 5, now we get the error that I was expecting. Must provide a procedure body when using a code allocator. That might sound a bit weird, but maybe we could make that a little more, a little less obscure, because people might look at that and go like, what the hell is a code allocator? This is a bit weird. Like, we don't have to do return. We can just return. This is like the do return is just the same as this. You know, we make some little temporary scope and we do it. So it doesn't matter if we do or not. Okay, so it's saying this must have a procedure body. So now we can go equals. We said it will always return 5. So that's why these two return 5. So let's go me. And now we get our 32s. Okay, so I'm happy that we fixed that return bug. Let's chuck that off the list. Now I want to expand on our generics. Yeah, so this session is mostly going to be generics, I think. We might get into something else if we, at some point, let's see. But at the moment, I just want to try some new things that I'm not sure if they will work. So this, for example, we know in the context of this procedure what a $t is, so we should be able to declare a variable of $t, type $t. That should be fine. I'm not sure that it will be. Okay, it's not happy. 2 byte size is probably $t, is it? Yeah, it's $t. Okay, so how do we make sure that we get the correct type in there? I feel like this is still type checking business, you know, resolving types. So let's go to the call and see what we do here. We resolve the types in the procedure type node. I think that makes sense. So this is within the body. So within the body, we don't know what a $t is. So we've gotten these placeholder identifiers. This is where the $t is. It's in here. We've added to the call context, but this is just a temporary context, so it's not going to get saved anywhere. And that's it, apparently. We don't do anything else with it. So I think we need to come down here. I guess when we create our concrete procedure, we've already created the concrete procedure. So just at some point down here, I don't think it really matters so much where. We want to get our concrete procedure and add identifiers to it. I think that's basically it. I don't know, let's see, does that help? Yes, that does help. Okay, so it's happy now. And if we go to the playground, oh, here we are, return me. Yeah, we have two statements now. And the first one is allocating 8 bytes and assigning nil to it. So this is the 64 variant. I guess the 8 variant is here. So this one's assigning 0 or nil to 1. So if we go equals 43 maybe. Here, now we can see that we allocate 1 byte and we assign 43 to it, or 8 bytes and assign 43 to it. Cool. Okay, happy with that. Now I want to just try, because there's a couple of procedures in the standard library that would be nice to have generic. So let's see if we can do that and see what issues we come across, I guess. So if we go standard lib strings, there's this I to A, where you have to put in an I64, which is a little bit annoying, like in our playground. See here, we're casting this to I64. I don't want to have to do that. I think we can take these off too. Should be able to do that. And this one, like so. That's nice. I don't think there's anywhere else where if I go to bang code only. Yeah, there was nowhere else that we casted. Okay. So now if I make this $, I'm going to call it any int. Like I could call this whatever I want. It doesn't really matter. I do want to be able to restrict this so that you could only pass in any int. Like right now, floats would probably, you could probably pass a float in. It wouldn't work, but I'd just give you some garbage, but you could probably do it. So what happens if we run this? Okay, doesn't work. Why? Looks like we are trying to get a qualified name. The identifier path is empty. Looking for the identifier path for procedure node. We have to be careful here because we changed the name of procedure node to this. It used to be just I to A before this line. So it can't find I to A. Yeah, I think this is why, because I did take a little stab at this last time and to see what would happen. And I think this is what we came across. And I had to think about it. So I think when we're looking in here, this procedure node, it's going to do this stuff here. Oi. So we need to make sure that this module exists and that it's in the identifiers of that module, which I think it should be. Why don't we go here? There's an idea. Why don't we just step through this get identifier and see what goes wrong? Okay, so this is I to A. It's trying to get I to A. We're doing a call of I to A. We're inside a ranged 4, so this is definitely in the playground because it's the only place where we have ranged 4s. Okay, so let's step in. Is it a member? apparently it's not a member, I to A, but if we go to children, oh, it doesn't have any children. Why doesn't it have any children? I to A. So I to A would come through here. Okay. I think when we come in here, we're processing the parameters and we get here, so we're deciding like this is a generic procedure, we need to make a copy of this. And so we get everything we need. We create our copy, or we populate our copy of the procedure, and then we say, okay, we need to update all of our local variables. And also we're overriding the procedure node, which is this node here. That we look at, this identifier node right here is this node. And we're just assigning it. So because this would have a child, which is strings. So then it knows to look in the strings module. But because we're just like overriding it with this concrete procedures left-hand side, which does not have that child, then we're in trouble. So I think really it's the type stuff that we wanted to have a copy of, because it's going to resolve the types in that type node, and we don't want that to happen to the original. Yeah, okay, so I think we shouldn't assign to this. We should instead assign to the data type of that. And then we should, so this should be the procedure data type, and then we'll update our references still. But that means that we should maintain the original procedure node. This identifier node we should maintain. So it should still have a child. So let's go, I was expecting it to, like, I thought I had a breakpoint or something. But now we end up here with an error. Maybe I did have a breakpoint. I don't remember, to be honest. Oh, I did have a breakpoint, yeah. So what's wrong with this? So I'm saying the data type, the data type should be this data type. Okay, that makes more sense. Do we get to our breakpoint? We do. Okay, so now our procedure node, I to A, should have a child. Okay, it has a child, which is strings. So then when we step in, we go into the member part. So now it's like, okay, I'm looking at a module. Yeah, I'm going to import it, and I found it. Okay, so we step out, and we should have a nice identifier path. It has two elements. Yeah, okay, cool. Okay, canon negate type U64. Okay. Oh, before I forget, something I thought of here was, what if we have already created this concrete procedure? Like if we call I to A twice with the same type, so if we call it twice with an I64, both times with this code, we're gonna assign the concrete procedure, we're gonna reference, we're gonna do all this stuff that we don't need to duplicate. So the reference is gonna enqueue type checking and stuff, so we're gonna get double. We're gonna double up stuff that we don't need to. So I think, do we need to do any of this? I think all of this except for this part. This part we need to do. This part we need to do. So we do need to sort out the name. This I don't think we need to do. I think all of this we don't need to do. We just need to set the name so that we refer to the correct procedure, which has already had this done for it. I think that's it. Are we doubling that up? I don't know. Okay, so if, let's put this in here and say, if this procedure name is not in, we need to get the qualified name. Parent qualified name. So we do, is that what we get up here? This is the qualified name. Yeah, get qualified name. Okay. I might take this out and put it up here somewhere. So this is the path to this procedure. So then we can produce a qualified name from it. And then down here, we want to also produce a qualified name from it. But we need to update the last element. So procedure path. The last element needs to take on this new name. This is the concrete procedure name. So procedure path, the last element. Procedure path gets updated that, then we get the correct qualified name. Then we can say if qualified name is not in our list of procedures, which is to say if this has not been done yet, because we put it in there, yes, so this here we don't need to do anymore. It's just like that. An identifier path, we already have parent qualified name. Yep, that's good. Okay, so yeah, we got the qualified name. Let's say concrete qualified name, just to be clear about that. Okay, so that should prevent duplicating that. Now okay, cannot negate type U64. I think that's because we have this negation in here. Yeah, this is the line. And we're passing, like this is a U64, and this is legit. You're not allowed to negate a U64. So I think what I'm going to do is I guess it's like this I64 value. So we're going to cast the value to an I64, and we're going to use that here. So that does mean that if you put a big U64 number in here, it's not going to handle it properly. But it will work. So basically we're forcing it to be a signed integer so that this part works. I don't know if it's probably not the best solution, but I think it should work. Or maybe it will not. Where are we? Okay, this is where we are resolving the name of something. What does our identifier path look like? It's got nothing. So it's not found. So what are we looking for? I2A variant I64. So let's say if node dot value equals I int equals 0, I plus equals 1, just gives me something to break on. Copy that value into there. Oi, sometimes it just, I don't know why, sometimes it just crashes before it even gets to my code, it seems like. There we go. Okay, so let's step into here. So it's that, I'm guessing it's going to have, yeah, it's going to be strings. Okay, so we should go into here, yes. Get our module, we find it, good. Get our imported module. Look in the identifiers of the imported module. We put it, where did we put it? We did this right. We put it into the procedure, but we didn't put it into the module. If we go to type check module, so the identifiers from the context go into here when we type check, but that's not going to solve this problem. Oh, I think it, so this module, in this case, the core strings module, would probably most likely get type checked. Doesn't, not necessarily, but in this case it does. It will get type checked after this happens. And it just overrides the module identifiers. So that's bad, because if we put something in here before this module gets type checked, then it's going to get demolished. The other problem is that we put it into the procedure, not into the module. And I don't think there's anywhere that it's going to get copied to the module. Like if we go module.identifiers, find usages, and see where we copy into it. This is looking through it. It's always on the left. Yeah, the only place that it appears on left is here. This is the only place where identifiers go into the module. But we're searching, where are we? We're searching the module identifiers in this case. So maybe instead of putting it in the procedure, I should put it in the module, if it's a top level thing. So if the identifier path equals 2, and it will equal 2 if it's a top level thing, if it's part of a module. In that case, we get the parent module and add to its identifiers. So that'll be, we get the module with that name and add it. And maybe we need something like this over here. So we go through the context identifiers and update the module identifiers. So we just add to the mod. We don't like override the whole thing. We just add to it now. So that should not clobber this. Okay, let's try that. Okay, this is where we had our problem. If we step in, so it is in the identifiers. We found it. We found it. Okay, let's make sure we get rid of this. Wow, and everything's running. It all looks good. Okay. So I2A is now generic, just like that. I mean, if we look in here, I2A dot variant. Yeah. Oh, so this is the 64-bit U variant. There's the return me64. There must be more variants of the I2A one. I2A is quite long. I really do want to optimize the assembly. I think it's much longer than it needs to be. Let's go up. Okay, there's an I8 variant, a U8 variant, an F32 variant. You see, you can pass an F32 and that doesn't make any sense, but where do it's probably in the playground. Where do I do that? Foo? Yeah, it's this one. Well, it prints it out, actually. Wow. Oh, yeah, I guess it works well, these are integer values. If I did like 2.5, it would probably freak out. It just says 2. Okay. Well, that's not bad. It's not bad, actually. I thought it would crash. Okay, we'll just allow that for now. Later, I think we should be able to restrict what goes in. Let's say restrict generic param types, something like that. Okay, but I'm happy with I2A. The other more complex place, which is why I left it till later. Where are we? Half an hour in. I think we're doing really well, actually. Half an hour. And we're really, I don't know, I feel like the generics are getting much better. But let's go to threading. And let's try start thread. This procedure here is some crazy shit. But basically, I don't like the term arg. So everywhere that shows up, I want to change that to param. And I don't want it to have to be an I64. That was just kind of a stopgap because we couldn't just pass anything. But now, maybe we can. Where do we call start thread? Down here. So we don't need, like we can just pass in a pointer to a thread portee. And then in thread pool worker, we can just say this is a thread portee, like that. I kind of don't like that parameter names are part of the type, and I've did some thinking about it. I'm not sure whether they need to be. I want to do some testing, like basically I want to relax the type checking so that in one place it could have one name, another place it could have another name, but they can still be used interchangeably, and see whether it works. I have a feeling that it will actually work, but right now they need to match. So anywhere where we had pool, see, it would be nice if this was pool, so I didn't have to do this, because this is not the best. Okay. But that's nice. We got rid of quite a few hash dangers. We only have hash dangers in here now. So that's nice. And this is crazy shit, so this kind of needs it. So let's see. Currently this, I want to change this, but I think this will still work. Because this, we're still passing the same thing in, right? It's still got, the thing I'm worried about is how big is this? And are we, copying it into the stack correctly and that sort of thing? But I think we are. But we're not actually executing the thread pool. So another thing is we should probably switch over to our OpenGL example. Maybe change this guy so it's not a compute shader. So now Boomstick is going to run on the CPU. He's going to call this procedure with this data, and he's going to use the thread pool, and he's going to start some threads. And what happens when he does that? Crash, probably. Yes. Let's see why. Okay. What is value? Value is a reference, which is probably fine, but somewhere in here it's not happy because that's null. Yeah, I think I've come across this a few times now when I was playing with it, but I've never come across it when I'm recording. We're looping through these param nodes, but we don't actually use param node. This should be param node. Okay, so now this big crazy ass type, which is very long, and I64 are not compatible. Where is this? Threading 43. Right, because this is expecting I64s, and this is no longer an I64, it was. So I'm just going to do danger untyped so that it ignores the type of this. It should still work. It should still work, I said. Let's have a look-see at what the issue is. 1172. Okay. So this is not a valid procedure name. It's ridiculously long. I think it's still going to need to be ridiculously long because it needs to contain all the type information, and like we saw before in that other error message that we had down here, the type name is very long. We're just going to have to make a different variation of the type name, I think, because the type name that we have at the moment, this one that we're creating here in type name, it's nice for people to read. It's human readable. That's the idea of it. But it's not nice as a variable name. So let's go type var name. Before I forget, we should probably, everywhere in here that we see type name, is that all of them? I think it might be. If I click on type name up here, all of the highlighted ones, I'm looking in here. This is showing me where there's other instances of type name and they're all above here, so that's all good. Okay, so now let's change all of these. So this is the directive. I think instead of following it with a space, so this is going to be like, you know, this is the hash line 4. So instead of having a space here, let's just put a dot. Dot is the separator that we use. And now in these names, right, there's lots of dots. Okay, so they should take care of that. This is a reference, so let's go $ref dot. These should never appear because this is, we're already fully type checked, so we should only have concrete types. In the case of an array, let's say $array dot. And these, and I think we don't need anything here. Question mark should never appear. So it should just be this. Oh wait, we lost the length, didn't we? So I should probably go like in here. Or maybe after actually. Maybe after. Dot length. So it's array and then the type of the array and then the length of the array, which should never be this question mark. So I guess we could just put this. Let's just go like that. It's nice to have length there, so it's obvious what it is. Oh, but it's the value. Like so. Okay, on to the next one. Enum should be like $enum dot, and then all the enum member names separated by dots, I guess. And the member names are these. They should be fine. They should be valid identifiers. This is procedure parameters. So the procedure is going to be like $procedure dot. And then I guess we'll say like the name of the parameter dot the type of the parameter for each one, and we'll join them with dots. Oh, and this arrow thing, this is for the return. I guess we'll say return dot. Return dot? Yeah, I think return dot. Okay, a slice, let's just go $slice dot instead of having the brackets on the end. And a struct, also going to have the name of the member and the type, similar to what we did with the procedure. And we'll go $struct dot, put dot separate the members, get rid of this. I think that should be a nice, well, not nice, but it should work hopefully. So we need to use that in our call. Here we use type finding. Okay, that's actually running. Was that all we needed to do? So now we still have a crazy long name, but it's like all valid as far as the assembler is concerned. Okay, making very good progress. So now I kind of want to improve this, because right now it's assuming that everything is an I64 size. This here could be anything, so it could be any size. A procedure is a pointer, so that's always going to be 64-bit. or it's always going to be the size of a pointer. I'll say that. So let's separate out our parameters. So the first parameter is U64. Second parameter is U64. So let's say that this is a pointer to a U64. So this is a stack func. And then this is a pointer to a U64. This is stack param. And then we assign param to it. So basically it's like we've created this stack. We've gone to the top of the address space. So this is just like the stack that we normally use in assembly. So now this is our sub RSP, which I don't know if you guys remember that. See, like, yeah, sub RSP. So we subtract from the stack pointer, and that's how we allocate on the stack. So here, this is effectively subtracting from the stack pointer to allocate enough space to allocate 8 bytes. Then, so this here actually is an address. This is a pointer. So we cast it to a pointer, and then we assign this to it. I guess we didn't actually have to cast it to a pointer, but yeah, we'll get to that soon. Let's just see if this works. So we've introduced another variable. So now I think we need 6 here. 1, 2, 3, 4, 5, 6. This will actually be a slice, which is 16 bytes. And then there's 1, 2, 3, 4 others. So that's 6. You know, I was always confused about this because I remember when it was 5, it was actually 1 higher than I expected it to be. If we go to 7, that still crashes. But I think it should be 6. It's like 1, 2, 3, 4, 5, 6. This is like accounting for all the variables that we have here, because the child process is going to start from after this gets returned. So it's going to, the first thing it needs to do is assign to this, and its stack needs to be set up in a way that it can still access the parameters. So the parameters are on the stack. We put the parameters on the stack, and then we allocate enough space so that we can get down to where PID is. We can still do this. I wonder why this doesn't work. But I'm curious why this number is not right. And I have a feeling if we go to, so what is this? Start thread. If we go, here's where we define it. And this is our syscall. Yeah, see, there's this extra allocation, deallocation. One of these is allocating the return space. That's where the return value of the syscall gets assigned. That's this part here. But this, I think this is like on Linux, 64-bit Linux, normally for procedure calls, you need to align the stack to 16 bytes, and that's what this is doing. You don't need to do that for a syscall, which is why I have not accounted for it, you know, when I'm building up my stack. I've not accounted for the fact that it would, allocate 8 bytes before calling this, because it shouldn't, and it is. So if we go to generating a call, yeah, see, it's this here. When we're generating a call, it checks like, are we 16 byte aligned? And if not, then we adjust how much we're going to allocate and stuff. And then we do the allocation. So yeah, so I think basically we just don't want to do that for syscalls. Xterm we do want to do, just not for syscalls. Okay, we still get a crash, but at least see here now those lines are gone. There's only one allocation. There's no deallocation down here. So that's better. But why is it still not working? Oh, I think we need to, so this is an address in here. So we treat it like an address in here. But then we want to say the value at that address is func, so we need to dereference. Maybe that's it. Hey, there we go. Okay, so that's working. Now I want to change this a little bit more. I want to make it a little more, like, make a bit more sense. So I mentioned the stack pointer before. So effectively by doing this, we're saying the stack pointer is at the top of the stack. So that's what this was doing. These two lines don't need to be there. Now, like I was saying before, we subtract from the stack pointer. And we say, a pointer to this place in the stack is what we want. We want a pointer to that place in the stack. That's where our function should go. And then we assign it. Again, we allocate onto the stack. And then we say, okay, whatever's there, we want to assign to that. Then we allocate for the instruction pointer. I think I want to modify this a bit more later on because this is not quite right either. Like so, and then the pointer to the stack after all these allocations is what we want to pass in here. And we'll have to do untyped because it's expecting an I64. Okay. Yes. And that actually worked first time. Kind of surprised. Okay, so maybe the next thing, because it's a bit easy, is we will divide this up. So this is the instruction pointer. I'm going to go plus. And so the next thing we need to allocate, so this is basically us allocating a bunch of space in the stack to account for everything that's happened in the procedure up till this point. So first thing that happens when you call a procedure, like start thread, so the first thing is we put the parameters on the stack, right? Then we call the procedure. And what happens with a procedure call in assembly is that it pushes the instruction pointer onto the stack. So we need to account for the fact that the instruction pointer is on the stack. Then we need to account for all of these variables here that we are declaring. So stack, okay, so let's try this. Stack is a byte slice. This is actually a pointer to a byte. Well, I'm just going to say this because it's a pointer. All pointers are the same size. It doesn't matter what you're pointing to. So it's a pointer. This is a slice. Again, it doesn't matter what it's a slice of. It does happen to be a slice of bytes, but it's the size of a slice. So here we can say this is stack. Okay, what else do we need to allocate? Stack pointer is the length, so I'm going to call that a U64. Technically right now it's an I64, but we want to change it to U64 at some point, so let's just make that U64. They're the same size. Stack func it's also a pointer. So let's just call it a pointer to a byte. Doesn't matter what it's a pointer to. Stack param is also a pointer. And PID is an I64. That's what gets returned from the syscall. Again, I'm going to call this U64 because I actually want to change it to a U64 at some point. And I feel like I'll probably forget it here. But so those should all be the correct sizes. I don't know if that's going to work though. 55. It's actually this line that it's not happy about. But I didn't, maybe it's because of this. Not a very nice error message, is it? I need to improve those. Okay. 48. Pointer to I64 and I64 are not compatible. I think it could be because it thinks that it's like, it's probably taking byte size and then taking a pointer to that. So maybe if I do that. Now 50, so these need to be I64s. Damn it. Because stack pointer is an I64. So when length changes to U64, it'll force me to update these. So probably 51 will have an error. 50 still. I64 and pointer to I64 are not compatible. I'm going to update these just in case this is what the actual issue is. Okay. It's generating a reference. Oh geez, look at all these expression ones. Okay. I was kind of hoping there'd be an assignment so I could see the left-hand side, which kind of gives me... Okay, so it is this big... Well, of course it's that big math thing that I'm just changing now. So what is this actually? It's a reference whose data type is also a reference. That's a bit weird. And the child is U8. And it's trying to generate a reference. Yeah, so I think it's like trying to evaluate this as a primary, but when it comes across this, it's trying to do just the normal thing, but because this is actually a type, it should not do this. How do we handle types? Just return nothing. I think, because this is not getting caught here because it's a reference to a type, I think we should never get here because we should instead say if is type, return nothing. And this will catch like references to types. So if we go in here, like see if it's a reference, then it'll be like, well, is the child a type? And if the child is a type, then I consider this also a type. So this is basically an early out. Like if we're looking at a type, there's no generation to do. Let's just quit out. Let's see if that helps. Seems like that helped. Okay, we're taking baby steps here. There's still more generics that I want to throw in here now. So I guess this is actually the size of a pointer. that we want to do here, and it's actually appointed to this procedure. So then we should not need to danger untyped, because this is a procedure. So if we're dereferencing a pointer to a procedure, well, then these two have the same type, right? I thought that was taking too long. Okay, what's it unhappy about now? Is static procedure. So what are we looking at here? Left-hand side node is a dereference. Yeah. Dereference of stack func. Yeah, so it's this. So it's dereferencing stack func. And it's going into, it's checking whether it's a static procedure, and it does have type procedure, because it was appointed to a procedure, but then we dereferenced, so now it's actually a procedure. Interesting. So I guess is static procedure. Yeah, it's expecting an identifier, but what I passed in was not an identifier. It was a dereference. So maybe we need to also make sure it is an identifier. Yeah, I think it needs to be an identifier. And if it's not, then it's not a static procedure. If it's not an identifier, then it's not a static procedure. Okay. Oh, got it wrong again. Or that's one of the conditions. That means it's not a static procedure. Okay. Hopefully this works. Okay, that worked. Okay. Great. We went from 2 of these to 1. Okay, so now down here, this is actually a pointer to a $T, so we don't need to danger untype that. Good. Wow, it's going so slow. Oh, it's because we have a couple of these running. My CPU is probably unhappy with me, because these windows, they're designed to do a lot of work, and I have a couple of them running. Okay. Right. So that was good, but we're still assuming that it is a U64 site. So really we want to do this. I think this is not going to work. Yeah, because we're not allowed to put these on right-hand side expressions. So, well, that's a grammar change. So where is it? Placeholder. We want to add it to the right-hand side expression. Put it there. There. Okay, so right-hand side primary, can have a placeholder. And to implement that should be very easy. We just go back to our primary placeholder and we say if type is left-hand side, which, because the only types of primary you can have is left-hand side, right-hand side, and type. And now we're allowing right-hand side and type, but not left-hand side. So left-hand side is the only one we don't let use $T, and that works. Because $T is a known identifier in the context of this thing, so it gets replaced. Wicked. Okay, so that's the right size now. So I think this is more intuitive now. You know, we allocate the correct amount of space on the stack, and then we assign. Allocate more space, assign. We're accounting for all the other things that need to be allocated. Wicked. Okay. I'm pretty happy with that. And we're at 1:06. I'm kind of wondering if there's like maybe some quick things we can do. We talked about negative. Well, you know, I'd like the length. Where were we? Here. Like I'd like this to be a U64. I feel like that might be a bit dangerous to tackle now. But what else did I notice in here? Down here. Oh no, it was something I noticed in the code, actually. This here I kind of don't like. You see how I'm using comments to say what these parameters are? I feel like we could just make a futex wake and futex wait. And then, so it would have that there. We don't need that. We don't need that because that doesn't matter. And then in this procedure, we can call this parameter count so that we don't need to be like, hey, what is that? I think that'd be nice. So, that's just a nice, simple little thing to do. That's in OS Linux. So instead of having futex, let's have futex wait and futex wake. And then if we go back here for wait, we use 0, and wake I think was 1. Yeah, wake has a count. So it's just going to be a count. Like so. And this has an expected and a timeout. So it'll be like that. I think that's much nicer. Okay, so now I don't need these comments. And there should be some errors where I use it somewhere else. 136. So this is futex wait. Expected 1, timeout 0. That looks much better. Okay, threading 11. Oh, here's a couple. Futex wake. Boom, 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 boom. Just like that. Any more? I feel like we're going up and down in this file. How does the compiler decide where to tell me there's errors. Feels very random. So that's awake. Yeah, I was going to change this to i64 max. Let's not do that right now, because I think integers need a little more love. Okay, let's fix that one. That's an hour 10. And I think right now I'm feeling pretty good with this. I'm really happy with where our threading, like our start thread procedure has got to. I think it's a lot more clear to me. This is really good, I think. Yeah, and this really obviously is like allocate on the stack and assign to it. I can pass anything into a start thread. It's really nice. Thread pool, though, is still very specific to Boomstick. It wants Vec4 and stuff, and we can't do a generic struct. So we can't resolve that, really. Yeah, so that's another thing. So we can get into generic structs, I guess. And the other thing is, so I still have this here on my multiple course. Oh yeah, so I made a note of that. Yeah, we solved that, didn't we? So now, I think the only thing left in generics is generic structs. I don't know if there's anything else I want to do with generics. And that would include, if I had like $t, then I wanted to declare one of these guys. I guess that's where we get into the angle brackets, right? And then we would say vec4 to specify what $t is. But then what makes me curious then is this: if I had $t$s and I said vec4, vec3, how does it know which is which? I mean, I guess intuitively this is the first one, so that'd be that one, but I think really you'd want to say something like this, so that you know which of these correlates to which of those. So yeah, so structs, generic structs, and the other thing that we're going to need for Boomstick, really, to make it nice and generic, is right now when you call bang, you pass in this. So we could say that that's $t. That's fine. I mean, that would probably actually work. Does that work? Yeah, that works. That's crazy. That's crazy that just works. But the thing is that really I want to pass in like more than one thing, more than one array, and be able to act on more than one array. It's quite limiting just to be able to work on one array. Yeah, so that is going to require variadics, procedures that can take variable numbers of arguments, variable numbers of generic arguments perhaps. So that's why I got these two here. This ternary is kind of like, it's annoying me a bit. I'm going to put it down there because it just feels like I have to get my head around it. It seems like a simple feature. It looks like a really simple feature, but I'm just not sure exactly how to tackle it yet. I haven't put much energy into it. And these two are like, those. If I had those two, I feel like, wow, that would be pretty cool. So yeah, okay. Did I undo? I did undo that. Okay, great. Thanks for stopping by. Have a good one. Ciao for now.